So thus the sum of n terms in a geometric progression Sn, which is given as r into last term minus first term by r minus 1. This is the simplest method you employ to adopt to find the nth term. You will find Sn, you will find Sn minus 1. The difference between these two gives the nth term. We will separate it till here. We can take out 2's and we can calculate the sum of this. We'll introduce 2's in here and we'll proceed further from there. Here is a very important approach. We have the sum of the numbers and their ratios, that is given as 11n minus 17 and 5n minus 21. What we have to find is we have to find a ratio. The ratio of 16 terms, it is given as this. Okay, and the 16th term is the average of the first 31 terms. The ratio of 16 terms in equal ratio of the sum of 31 terms of the two series, right? So we can say it like this. By this formula, if it is 32 minus 1 by 2, and if we, so this term actually means the sum of 32 terms and the sum of 31 terms, because here it is 15, right? So x minus 1 by 2 is equal to 15. So like this you will get 31. So we substitute 31 in this and we will find the required ratio. The one thing to notice in this problem is the nth term of a certain series is this many times the nth term of this. So obviously the sum of this series will be this many times the sum of this. We got to find the nth term of the first 12 terms in the series. So we'll take Sn. We will shift one digit to the right and we'll write it, and we'll subtract these two and we'll get Tn, and this is the Tn. From there we will take the Sn. We got to find S in this. Actually we multiply this with x, we'll get this. We'll subtract these two and again we'll get third, which is not yielding any result to us. We multiply it with again x and we got one equation. Now we subtract these 3 and 4 and this infinity CB a by 1 minus r. Okay, from here we'll get x. The important thing is we have to carry down the steps multiple times. This is a very good problem. If there are 13, arithmetic means inserted between 10 and 80, which means this is the first term and then this is the 15th term, right? What is the fourth term? Fourth mean. So we can consider it as the fourth term and we can find it like this. This is a beautiful problem. I have seen similar kind of problems where I will actually take this or this and make the base uniform or the power uniform. But now we have to convert everything into 2's, power of 2's to be specific, and we need to compare all of them. We should have a sound grip on the 2's and powers of 2's and powers of 3's as well. directly I am unable to find the root of this equation, but what I can do is I can multiply it and divide it by 2. Always have that option, because anyway you cannot take 2 outside from this 5, but you can multiply and divide it by 2. You should consider that option. If you need to find the greatest among these, I try to think to bring something out, but the other option is you can always square. Then we need to approximate. The trick lies in the approximation. If you are sound with your square roots, this is a walk off. It is an easy walk. What is characteristics? See, the characteristics of the common logarithm of a number greater than unity. See, this is a number greater than unity and is 1 less than the number of digits in the integral part. So it is greater than unity, so that means greater than 1. So it has 3 digits in the integral part, which means 2 is the characteristics of this. And whereas if this number is a decimal which is less than 1, the characteristics is negative and it is 1 more than the number of zeros immediately after the decimal point. So there are 2 zeros immediately after decimal point, so it is -3. So this is the character of the logarithm. So the mantises are the same for logarithms of all the numbers which have the same significant digits in the same order. Now mantises which are necessary to solve the problem are usually given as, for example, you have to find the value of this. Now what is the characteristic? 1 more than the number of zeros immediately after the decimal point, so that is it's -2 bar, and this mantis is 3010. So the mantissa is same as log 2, hence the value is this. Here if you see a log b, a power log b is b power log a. This is quite important. Here 2 bar is negative, right? So if you convert it to positive, like if you simplify it, you will get this. So this is also a value of this. You have to remember it as well. What is log 2 and what is log 3? Log 3 is 0.4771, whereas log 2 is 0.301. See, 2 ka 3, 3 ka 4. So we have to find the number of digits in this. How do you do that? First of all, can we find the number of digits? We have to take the log of this, and we will go to 2 log 5 plus log 3, and then which is this, and from here we approximate it to 226, and so 226 digits is the answer. You will already know most of the series. Just have a glance at these other series. Sin x, obviously there is factorial, yeah. Cos x, yeah. And sin hx, and sin x are, say, okay, let's keep this for some time. Log x, you should remember this component. It's x minus x square by 2 plus x cube by 3 minus x power 4 by 4 and so on. E power x is e power x starts with 1. The irony is here you don't have 1 but it starts with 1. Here it's 1 but it doesn't start with 1. It's 1 plus x square by 2 factorial, and obviously log don't have a factorial, whereas e power x has a factorial. Let's so on. And a power x has x log a. In place of x you substitute x log a. From here you will know, right? 1 plus x square plus x cube plus so on. This is the triangle number. So obviously they are triangle numbers, right? 4, 3, 2, 1. So this is the important thing. Any whole number can be written as sum of at most 3 triangle numbers. Fibonacci series is sum of previous number and present, 0, 1. These two is this, and these two is this, and these two is this. So like that. And this is how you'll arrive at the Fibonacci series. You'll write all ones, 1, 2, 3. So okay, you got this, right? 1 2 1 1 3 3 1 1 4 6. So actually this is 1, right? 1 plus 1 1 1 plus 1 is 2, 3 3 3 plus 1 4, 3 plus 3 6, and again 4. Then you'll start calculating in this way and you'll get the Fibonacci series. And you can actually write these numbers as per this. So this is the Fibonacci series, right? And as well as if you try writing a power 6, see the coefficient, right? So this is actually, this can be derived from this triangle. So you have to have a note of this. So for a number, the sum of its factors is less than itself, then it is called deficient number. And only one number in the list above, sum of its factors is equal to itself, which is called a perfect number. Perfect number is 28, whereas 6, which is 1 2 3, which is a perfect number. This is look and say sequence, not necessary now.